Hello everyone, I welcome you back in the machine learning course. So I am Siddharth Kumar Jha and today I am going to talk about hierarchical clustering and dimensionality reduction. Okay, so hierarchical clustering and dimensionality reduction. So first we will understand about the hierarchical clustering. So what it is basically. So it is like unlike k-means, like no need to pre-specify the number of cluster. So in the k-means clustering, we have to identify the cluster first, k value. But in this, there is no need to predefine the cluster value k, and it is a build on a hierarchy of clusters like visualized using the dendrograms. Okay. So let's go to the notepad for the better understanding of these all topics. So without wasting time, let's get started. Okay, so here is the hierarchical clustering. Hierarchical clustering. So what it is? So in this, unlike k-means, no need to pre-specify the number of cluster. Pre-specify number of cluster. Okay. So in this, we are builds a hierarchy, builds a hierarchy uh, of the cluster and then visualized using the dendrogram. Okay. So next, we will understand the type of hierarchical clustering. So here, let's go with the types of hierarchical clustering. So first type is your like algolometric, 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 which is nothing but your bottom up approach. Okay, so it start with each point. So it start with each point as its own cluster. Okay, so basically we are like merging it. Okay, so basically merge. So we will see it like the graph, like how it will work. So basically, suppose here is your root node. Okay, so basically, there is some different data sets are there. Just suppose. Okay, so we will merge it together. Okay, so now again we will merge both. Okay, and again we will merge it to the final one. So this is nothing but your bottom up approach. Okay, so it basically helps when there is a large amount of data to reduce it in the smaller chunks, and then we are like working on it. This is called the algolometric approach, or you can say the bottom up approach. Okay, So the next one, which is, let me go to the second page. So the second one is your divisive, which is your top down. Okay, so it start with a very big, uh, okay, very big cluster and split recursively. So here what we are doing, so here there is some small uh, parts are given. Okay, so we are merging it for getting to the higher one. Okay, so just opposite we are doing in the top down approach. So let's see the graph. So here, suppose this is your root element, this is too big, and we are splitting it into some smaller chunks. So like this, we can split it. So this is how your top-down approach works. Okay, so just write it down in your notes. Okay, so let's move to the next one, which is your linkage method. Linkage method. So linkage method is simply a linkage, your single linkage, which is your minimum distance, and it is a complete linkage. There is one simple linkage, and there is the complete linkage, which is your max distance, and average linkage, and your Watts method. Okay, with it minimize the variance, minimize variance. Okay, so now we will see about the dendrogram interpretation. So basically, dendrogram interpretation. So what it basically do? So it cut the dendrogram at a certain height to decide number of clusters. Okay, so let's see some advantage and disadvantage of this. After that, we will go to the practical demonstration. So advantage is like no need to fix k in advance, and dendrogram dendrogram gives flexibility. So the disadvantage is like your first disadvantage is computationally expensive for the large dataset, computationally expensive for large dataset, and the second advantage is like sensitive to the noisy data, sensitive to noisy dataset. Okay, so let's do the practical demonstration of the Agglomerative and the Dendrogram. So for this, let me open my the Jupyter notebook. It will take 10 seconds, just wait. So let me minimize this and yeah, it opens. So let's create a new Jupyter book and select the kernel as your Python 3. Okay. And then we are going to write the code. Okay. So first of all, what we will do, we will import the library. Okay. So we have to import like some libraries like from sklearn. First, we have to import a dataset now. sklearn dot dataset import your make blobs, and then from you have to import the matplotlib as plt. So import matplotlib dot pyplot as plt, and then you have to import like the dendrogram and linkage. Okay, so from scipy dot cluster dot hierarchy, you have to import dendrogram and linkage, and you have to import one more thing, algorithmic clustering. So from sklearn dot cluster import agglomerative clustering, merative clustering. So just run this. So it will import all the libraries which is necessary. So here is one error, dendrogram. Okay. Oh, there is some spelling mistake maybe. So just run this. So yeah. So now I fixed the error. So now we will create the data. Okay. So we will write like x comma underscore is equal to make blobs, and you have to give the samples is equal to 100, and you have to centers, you have to give the center is equal to 3, and you have to give the random state is equal to 42. Okay, so just run this. So we have created the data. So now we will plot the dendrogram. Okay, so for that we have to write like linkage is equal to linkage, and you have to give the value. So x comma method we will give like rad, ward. Okay, so now we will give the dendrogram, and in this we will give like the linkage. Okay, so now we will give the title. So plot dot title we will give like the dendrogram only. Just copy and pasting it here. Okay, so now we will show it. So plot dot show. So see here, it has created the dendrogram. Okay, so just analyze this. So here some small data, and with adding this up, we have created one square, and then from creating it to the bigger one. Okay, so this is how it looks like. So now we'll apply the algorithmic clustering. Okay, so for that we will see here. So you have to write like SC is equal to hierarchical clustering is equal to Agglomerative clustering, and you have to give the cluster size. Cluster is equal to 3, and linkage is equal to your rad, WARD. Okay, and then we will give the labels. Labels is equal to HC dot fit underscore predict, and then we will predict the value of X, and then we will like we have predicted it, so now we will plot it. Okay, so for plotting it we have to write like plot dot scatter. Okay, and then we have to give the value, so X, and in the bracket we will give like semicolon comma 0, and your X value will be like semicolon comma 1. Okay, and the C is equal to labels. C is equal to labels, and you have to like C map is equal to, you will give V radius. V radius. Okay, and you have to give the title. So plot dot title. You will give like algorithmic clustering. Okay, so just copy it and just paste it here. Okay, and then you will show it. So plot dot show. Okay, so see here is the algorithmic clustering is here. So basically what it does, so it basically started from the very small data set, and we have merged it together. Okay, so this is the practical demonstration. So now we will talk about the dimensionality reduction. Okay, so for that let me go to the notepad. So here we will understand the dimensionality reduction. Okay, dimensionality reduction. Okay, so it is basically used for the high dimensional data to make the distance matrix meaningless. Okay, so the curse of dimensionality we will understand. Curse of dimensionality. So the first one is your like high dimensional data makes distance matrix meaningless and the visualization is difficult. Visualization is difficult and your overfitting is increases. Okay, overfitting increase. So for that, we have like one principle like PCA, principal component analysis. Okay, so let's see what it is. So principal component analysis, or in the short form, you can tell it like PCA. Okay, so the goal is to reduce while preserving maximum variance. Okay, so the goal is like to reduce dimension while preserving your maximum variance. Okay, so there are some steps. So there are five steps which involved in this. So we will write it like a step. So the first step is your standardized data, standardized data, and then the second step is your covariance matrix, compute covariance matrix, and then we will like eigen decomposition. We'll find the eigen decomposition. Okay, and then we will select top k. So select top k eigenvector. Okay, so which is like principal component, and then in the last we will project data onto new axis. Okay, so project data onto new axis. Okay, so the math behind is like we have to find variance captured by the principal component analysis, which is equal to the eigenvalue divided by total variance. Okay, so let uh, let me show you the demonstration of this PCA. So let me open the Jupyter notebook. So here we will create one new notebook. Oh, let it. I am explaining it here only. Okay. So here you have to import something. So you have to like import from sklearn dot decomposition import PCA, and then we have to import the dataset. So from sklearn dot datasets. Just a second. we will import your load iris. Okay, and then we will import the matplotlib as plt. Import matplotlib.pyplot as plt. Okay, so just run this. So it will import all the libraries. So now we'll load the dataset. So we have to write like iris is equal to load iris. Okay, and then you have to give the value like x is equal to iris.data and y is equal to iris.target. So here is the name issue like, oh, here I have written like iris minus iris is equal to. Okay, so now we will make the PCA. So PCA is equal to PCA and we will give the component. Okay, so and underscore components is equal to 2, component value is equal to 2, and then we will create the x underscore PCA is equal to PCA dot fit transform, and we'll give the value of x. Okay, so here we have make like we have fit the transform of our PCA on the value of x. So now we will plot it. So here we will give the code for plotting it. So just run this. So here it will create the PCA of the 2D projection. Okay. So I hope the demonstration is clear to you. So now we will move forward to the other dimensionality reduction technique. Okay. So there is two more which we have to talk. So let me open the notepad and go to the next page, and here the other dimensionality reduction technique, dimensionality reduction technique are there. So the first one is your linear discriminant discriminant analysis. Okay, so LDA. So in this, basically what happens? So it is a supervised dimensionality reduction technique. And the next one is your DSEN and UMAP, which is nonlinear technique for visualization. It is great for high dimensional data. Okay. So I hope because this is not in our syllabus, so I'm not going to talk about this in detail. So I just give you the overview, like the technique which is exists for the dimensionality reduction. So till now we have discussed like the clustering. So in the clustering, we have did the k-means, which is very fast and simple and require the value of k in the starting only. Okay. After that, we have understand the hierarchical, which is flexible and dendrogram expensive. Okay. And it is little bit expensive. And next we have talk about the dimensionality reduction. So in this we have understand the PCA, which is linear variance based and it is fast, and then we have understand about the TSNE or UMAP, which is your non-linear approach, and it is great for the visualization. And we have also seen the practical demonstration of and PCA and before clustering to reduce noise and speed up the algorithm. So, so now we will take one example to understand the PCA. So, let me draw a graph, or you can say I am going to give you a table, and then we will see like how to reduce the dimension of it. Okay. So suppose one example I am giving you. So it should be your size, which is your x1, and rooms, okay, which is your x2. So data is given like 5, 3, 10, and 2, and here along with the rooms 10, 7, 15, and 4. So you have asked to calculate the PCA. Okay. So what you have to do? So in the first step, what I have told. So step 1, you have to calculate the mean. Okay. So mean, so x1 mean is equal to 5 and x2 mean is equal to 9. So 5 plus 3 plus 10 plus 2, how much? 20 divided by 4 is equal to 5, and its mean if you will take, so 36 divided by 4 is equal to 9. Okay. So now you have to calculate the covariance matrix. Okay. So now our step 1 is clear. So what was the step 2? Just recall. So step 2 was about to calculate the covariance matrix. Okay. So calculate covariance matrix. Okay. So how you are going to calculate it? So co is equal to the matrix looks like var of x1, variance of x1, variance of x2, and here is your curve of x2 comma x1, and here is your curve of x1 minus x1 comma x2, x1 comma x2. Okay, so how you are going to find the your variance and curve? Okay, so for x1, var of x1, var of x1. Okay, so it will be suppose there is a matrix A equal to this one, so you have to find y like a11. So a11 will be your 5, which is your mean here, the mean minus value. So 5 minus 5, I'm just zooming it out. Okay, so here is the 5, so x minus mu, 5 minus 5 plus 3 minus 5 square plus your 10 minus 5 ka square, 10 minus 5 ka square plus 2 minus 5 ka square divided by n minus 1. Okay, so when you will calculate it, you will get it like 12,67, 12.67. Okay, this is your A11. So like similar, you can calculate like for the A22, so which will come like 22. Okay, so now we have to find the what covariance of x2 comma x1 and x1 comma x2. Okay, so if we are finding for the x2 comma x1 or x1 comma x2, both will be same only. Okay, so let's see it, how we are going to find. So the covariance, let me see. So here we have calculated the variance. So now covariance, we will calculate it like here. So see, so the table I am writing here x1 and x2 and 5, 3, 10, 2. and here it was given like 10, 7, 5, 15, sorry, and 4. So its mean is like 4. What was its means? 5 and 9. Okay. So covariance, we can calculate it like first we have to calculate for the x2 comma x1. So we will write like 5 minus 5 into 10 minus 9, okay, plus 3 minus 5 into 7 minus 9 plus 10 minus 5 into 15 minus 9 plus 2 minus 5 into 4 minus 9 divided by 3. So how we have calculated it? So see, x minus x bar into y minus y bar. Okay, so we have to calculate this, and what are the value we will get, and we have to divide it by n minus 1. Okay, so this is how you have to find the covariance. So its value come like 16.33. Okay, so now our matrix is 12.67, and here 22 and 16.33, and here also we will get the same 16.33. Okay, so this is your covariance matrix. So now the step 3 was about the calculate the eigenvalues. Calculate eigenvalue. So how we will calculate the eigenvalue? So for calculating, we know the s minus lambda I is equal to 0. So S is your covariance matrix. Covariance matrix. Okay. So when we will do it, so we will get the matrix like what was the matrix? So here 12.67 minus lambda and 16.33, 16.33 and 22 minus lambda. Okay, is equal to 0. So from here we will calculate the lambda value. So how we will find the lambda value? So we have to cross multiply this. Okay, so you have to write like 12.67 minus lambda into 22 minus lambda plus 16.33 ka square is equal to 0. Okay, so from here you will calculate the lambda. So 2 lambda 1 and lambda 2. So I have already calculated. So lambda 1 is equal to 34.3 and your lambda 2 will be 0 0.4 minus 0 0.4. Okay, so here the 2 lambda value came. So now the question is like which lambda value we will take. So now we will take the higher value of lambda. So in this the lambda value is 13.4, which is much higher than minus zero point 0.4. So we are going to take this value as our lambda. So now the was step 4 was the calculating the eigenvector, calculating the eigenvector. So here we will calculate it. So the matrix was like 12.67 minus lambda, 16.33 and 22 minus lambda, and here it was 16.33. Okay, and we have like eigenvector is your u1 u2 and which it is equal to 0 0. So from here we will calculate the value of u1 and u2. So we will get the u1 and u2 is equal to minus 1.32 and 1. Okay, so Okay, so here we have calculated the eigenvector. So now the last step, which is like project data uh, onto principal component. Okay, so step 5 is your project data onto principal components. Okay, so here the data is given like x1. I am writing again x1, x2, and x1 5, 3, 10, 2, and here it was like 10, 7, 50, and 4. So we have calculated the eigenvalue and eigenvector. So here is the principal component we have to find now. Okay, so how we will find the principal component value? So this one will be our one matrix. So x1 comma x2 we will write 5 comma 10, and we will multiply it with the eigenvector which we have got. So eigenvector we have got like minus 1.32 and 1. Okay, so this is your 1 cross 2 matrix, 1 cross 2 matrix, and this is your 2 cross 1. Okay, so these two is same. So the output will be like 1 cross 1 matrix. Okay, so when you will calculate, so the value will come like 3.3. 3.3. When you will calculate this both, so the value you will got like 3.3, and like that. For this you can use your calculator. Okay, and so for 3 comma 7, when you will calculate, so you will get like 3, and when you will calculate it for the 10 comma 15, so 10 comma 15, so you will get like 1.8, and when you will calculate for the 2 comma 4, 2 comma 4, you will get like 1.3. So see here, this is how we have reduced the dimensionality of the data set. So here there was two x1 and x2, and which is we have reduced into the principal component in the single one. Okay, so this is how your PCA works. So we have seen the steps involved in it, and we have solved one uh, numerical example also, which can come in your college and university exam. Okay, so I hope this is clear to you. So by this hope, I am winding up the today's lecture. So see you in the next lecture of the machine learning. So tab tak ke liye keep learning and keep exploring. Bye bye.